let's spend a few minutes looking at the contents of the SoundLib library file. First of all, let's think about the fact that we've learned how to do a variety of things with pictures, and how if we take those algorithms in a general sense, we can apply them to sound. So for instance, we've learned how to copy pixels from a picture to a new picture. We've learned also how to mirror. We can take those same general algorithms and apply them to the samples of a sound and accomplish similar things. So first of all, we have the clip function. This would be similar to cropping a picture, where we're taking a portion of the sound and putting it into a new sound that we return. So we are giving it a source sound and then a start and end index values for what samples we're wanting to actually clip out of the original sound. Since we're going to create a new sound, we make an empty sound. We calculate the length by subtracting the starting value from the ending value, and then we get the sampling rate from the original sound. And since that comes back as a real number, we use int to turn it into an integer, because that's what's required of the make empty sound. We set an index to 0. This is going to be the index that we use for the new sound, the target variable. And then we've got a for loop, where it's going to go through all of the various indexes in that range, starting at start and ending at end. For each one, it gets the sample value from the original sound at that index. It then does a set sample value in the new sound target at the target index, and remember it starts at 0, and uses the source value we got from the line right above. And then the last step is to add 1 to our target index to move us forward. We go through the loop, grabbing all of the samples that we want, placing them in the new sound, and when we're done, we return that sound. So in a very similar way, the copy function is going to take one sound, the source, and copy the entirety of that sound into a second sound that we give it, the target sound, starting at whatever index we provide in the start parameter. And so we've created a target index, similar to what we had in the last one, that's going to start at the start value. And again, this start is where we want to start putting it in the new target. Again, set up the loop for source index and range. This time we've got 0 to the get length of the source, because we're copying the entire source. We get the value at that index from our source sound, and we set the value at target at our target index using the source value, and again increment target index 1. So source and clip are very similar to each other. The difference being clip, we are just pulling some samples from the original and creating a brand new sound. Copy, we're copying the entire original source and placing it into a second sound that we're given somewhere based on the start. A third function we have is that of mirrorSound. Again, we learned how to mirror pictures. The idea on pictures, we would get a pixel from one side of the picture and place that into the corresponding pixel on the right side of the picture, or top to bottom. In this case, there's only one dimension. We're basically doing a left to right movement of the sound sample. So we give it a sound, and in this case, by default, the mirror sound is always going to mirror the left half of the sound into the right half. And so we calculate the length of the sound and put that into a length variable. We divide that by 2 to get the mirror point, the middle. Enter into a for loop, going from 0 to the mirror point, the halfway point. We get a sample object at that index. We get the sample object that we want to place it into by calculating the length minus index minus 1. Very similar process to what we did with mirroring a picture. And then we get the sample value from the left sample, and we do a set sample value into the right sample. And that's the mirror sound. Again, very similar structure to how we mirrored a picture. It's just that we're working with samples in one dimension instead of pixels in two dimensions. And then lastly, we have the reverse function, which is very similar to the mirror. The difference is that mirror is only going to read half of the samples and place them into the right side in a mirrored fashion. Reverse is going to take the entire sound and invert it into a new sound. So it's like doing a complete mirror, but into a new sound. So we're giving it just the source sound. Since we're creating a brand new one, we have to create the empty sound to place it into. We tell it the length is based off of the original sound, -1. We get the sampling rate of the original, and then we set the source index to the length of the source, -1. Enter into our for loop, generating target index based on the range of 0 to the get length. We get the sample value at the source index from the source sound, the original. We do a set sample value at target using the target index and the source value from the line above, and then we subtract 1 from source index. Again, because we're going backwards, we're reducing the source index, gradually working from the end to the beginning. Once the loop finishes, we return target because we created it, and that's it. So again, reverse is similar to mirror, it's just that it's doing the entire sound instead of half the sound. We'll see you in class.